let's talk about the technique. Okay, we are talking about the derivative. Okay, so if you understand the meaning of derivative, and it will be easy. Okay, but keep that in mind. Derivative is talking about the slope of tangent line. Is it okay? So let's start from the constant rule. Okay, if your function is constant function, then the f prime must be equal to 0 with any constant. Does it make sense? Let me try to explain like with the sense of the slope of tangent. Okay, so when, for example, your function is the constant function, which means the graph will be just simple horizontal line. Is that okay? So even you choose any point on the line and think about tangent line at any point on the like constant function. Okay, then as you can see here, slope of tangent is equal to 0. Okay, in other words, f prime is equal to 0. So we can just conclude like this way. Okay, for example, any number 4 prime is equal to 0. Okay, or pi. Keep that in mind. Pi is not the variable, but is number, right? Pi prime or pi square prime, no matter what, equal to 0 as long as it is a number. Okay, so this is the constant rule. Okay, second one, power rule. Okay, and you have to practice a lot about this one because we're going to use this one frequently. Okay, so like your function is power function form, which means you have the variable on your base, which is x, and your exponent is number. Okay, does it have to be integer? No, it could be fraction number or integer or decimal number, doesn't matter. Okay, so as long as it's power form, then f prime must be equal to n times x to the n minus 1. So your exponent, your power is going down by 1. Does it make sense? So like, keep that in mind. Power rule is extremely important. Okay, so you have to practice a lot. Okay, and then number 3, constant times a function rule. Okay, it is coefficient. Okay, if you have coefficient, just like keep the coefficient in front of your function. Okay, so for example, let me give for example. Okay, here we go. If you have 4x cubed prime, that is equal to 4x cubed prime. Okay, prime means to take the derivative. Okay, so that is equal to 4 times, like we're gonna follow the power rule. Okay, it is 3x 3 minus 1, which is 12x squared. 12x squared is the derivative of 4x cubed. Okay, but like even I showed you like all the process, but like if you can do like from the problem to here, that's easy, right? 4 times 3, which is 12, and x cubed will be x squared. Okay, if you can do like this way, and that's really good for you. Okay, then like the next one is sum and difference rule. Okay, in your function is combined with like two function or subtracted. Okay, and like the derivative is working for each function separately. Okay, here we go. Your function f is g plus or minus h. Then f prime is g prime and plus or minus and h prime. That's it. Okay, and then the last one is really important. Okay, and whenever you have natural exponential function, then it is special function, which means e to the x prime is equal to e to the x. Okay, this is only one function which doesn't change it. Okay, does it make sense? Okay, that's it. Okay. Now let me give you a couple of examples. Okay, so well, like in this video, I can give you just a couple of examples, but I strongly recommend practice as much as possible. Okay, where can you find the resource? Like from your instructor's lecture note and web assign and textbook. Okay, or like anywhere. Like try to practice as much as possible. Okay, here we go. So g prime, okay, means take the derivative with respect to x. Okay, well, like in the previous slide, I didn't explain about this one. We also use a Leibniz form, which is dg over dx notation. Okay, so you have to getting familiar with this notation as well. Okay, it's just different notation. Okay, but same meaning. Okay, just take the derivative with respect to x. Okay, and what is that? Look at the first one, x to the 5, right? It's power function, right? X is your unknown variable is on the base, and your exponent is number. Then we're gonna follow the power rule, right? And 5x to the 5 minus 1. Okay, the second term, 8 is just coefficient. Okay, and then x squared, another power rule, right? 2x to the 2 minus 1, and minus 16x power rule, right? minus 16, and x prime is equal to 1, right? And then look at that. 2 is constant, so like 2 prime equal to 0. That's it, okay? And next one, pi square is also a number, okay? So pi square prime is also equal to 0. So that's it, okay? So let me simplify. That is equal to 5x to the 4 plus 16x minus 16. That's it. This is the derivative of given function, okay? So what about next one? ft prime, right? So f prime t, or in a Leibniz form, we can write this one as df over dt, okay? This Leibniz form is really useful because we will know like which one is independent variable, okay? T is independent variable and f is dependent variable, okay? So here we go. We have to find it, okay? So how can you find it, okay? Well, if you took calculus from high school, you know about the chain rule, okay? It is really tempting to use chain rule, but like for this point, like we didn't cover the chain rule yet, okay? We're gonna cover it later, okay? So like, we're gonna do the distribution first, okay? I'm talking about FOIL, okay? So here we go. So this function is to the FOIL, 1 minus square root of t times 1 minus square root of t, okay? Then it is 1 minus 2 square root of t plus square root of t square, okay? We don't need this parentheses, okay? Okay, let me try to write this one as a power form, okay? It's 1 minus 2. Square root is 1/2 power, okay? And square root of t squared is t. Now we are ready, okay? Let me come back. What is that prime? 1 prime equals 0, gone, okay? The second part, negative is coefficient, as I told you, don't do anything, okay? And then we're going to take care of t to the 1/2 prime, which is by the power rule, 1/2 t to the 1/2 minus 1, and t prime is just 1, right? So like, this one is equal to negative t to the minus 1/2 plus 1. Or if you don't want to use the negative power, then you can write this one as negative 1 over the square root of t plus 1, okay? But either way, doesn't matter. Let me give you a couple more examples, okay? Look at the C, okay? Function h of s is equal to s over 2 to the 5. Again, like, if you took a calculus before, then you know the chain rule. It is tempting to use chain rule, okay? But we didn't cover it yet, okay? Then what are you going to do? Let me take care the power 5 first, okay? So we can rewrite this one as s to the 5 over 2 to the 5, which is 32, right? So it can be written by 1 over 32 s to the 5. Okay, now we're ready, okay? It's just like power function, okay? Then h prime of s, which means take the derivative function h with respect to s, okay? In Leibniz form, dh over ds, okay? And that is equal to, coefficient is just coefficient, and then s to the 5 prime is 5 times s to the 5 minus 1. So your answer is 5 over 32 s to the 4, okay? What about d, okay? Well, again, like, whenever you encounter this kind of problem, like, if you know about the calculus and you would like to use the quotient rule, right? But if you do not know about quotient rule, forget about it. We will cover it later, okay? So, like, since we do not know the quotient rule, square root of x is your common denominator, which means we can split with 2 separate fractions, okay? I mean, look at that. That can be written by x over square root of x minus 3x square root of x over, because square root of x is common denominator, okay? Let me simplify by the power rule. This one is x to the 1 minus 1/2, right? Because square root of x is x to the 1/2, and since it's quotient, and it will be subtracted, okay? And then this guy just simply cancel out these guys, okay? So, or let me complete this one first, okay? 1/2, right? So your function function f can be written by this way: x to the 1/2 minus 3x. Now we are ready, okay? Now take the derivative, okay? Here we go. So f prime of x, or in a different form, df over dx is equal to x to the 1/2 prime by the power rule, right? 1/2 x to the 1/2 minus 1 and minus 3x prime is simply minus 3, okay? So that is equal to 1/2 x to the minus 1/2 minus 3, okay? And this itself is fine, but if you want to use the, if you don't want to use the negative power, then we can rewrite this one as 1/2 square root of x minus 3.